So let's go straight into question number 9a. We are asked to make m the subject formula in this relation. So we have m here and we have m here. All we have to do here is to make m come out and stay alone, not inside again. The first thing I will do is to multiply both sides by a square to eliminate the square root. All right. The square will cancel the square root. So m is equal to n minus m squared f plus 1 all over d minus n. This is m squared. Okay. So let's cross multiply in order to deal with the fraction. I'll have m squared equal to d minus n equal to n minus m squared f plus 1. So having done that, let's carry this m squared across to meet the border. I'll have this plus m squared f equal to, we have this and this, n plus 1. Then let's factorize. We have m squared here, we have m squared here. 1 can come outside. Then we have d minus n, and f is still here, plus f. All right, equal to n plus 1. To get m squared, divide both sides by the coefficient of m squared. I'll have m squared into d minus n plus f equal to n plus 1 divided by d minus n plus f over d minus n plus f. This guy will cancel this guy, so my m will be equal to n plus 1 over d minus n plus f. Okay, remember we have square here. So to get m, which is what we are looking for, we take the square roots of the both sides, so that square will cancel square root. I will have m to be equal to n plus 1 over d minus n plus f, all the square root. So we've been able to get m as the subject of the formula. But recall that we are asked to evaluate m given the values of the variables we have here. So we simply substitute. My m will be equal to square root of, my n is 3, okay, minus plus 1 over, my d is 8, minus n, which is 3, plus f, my f is 4. All right, let's evaluate. M will be equal to 4 over 8 minus 3 will give me 5, plus 9, 4, we have 9. The square root of 4 is 2. The square root of 9 is 3. So we have my m to be equal to 2 over 3.